Hello and welcome to JavaScript Marathon, a full week of free online courses in some of the leading web development technologies and concepts. Today's trainer is Jay Phelps, co-founder of Outsmartly. He will be presenting an intro training to Webassembly. If you have any questions after today, feel free to follow Jay on Twitter at _JPhelps. A special thank you to this week's sponsor, This.Labs, offering personalized training programs to suit your organizational needs, ensuring you and your company stay on the leading edge. If you find keeping up with constantly evolving technologies a struggle and want to bring your team up to speed on one of the latest technologies, contact us today at hi@this.co to set up your complimentary needs assessment. This.Labs is hiring. We are hiring technical project managers, engineering managers, senior software engineers, and DevRel advocates. Send us your info at jobs@this.co. We have a ton of upcoming events happening next month, including State of GraphQL, State of Angular, our Women in Tech Monthly Mentoring, and Modern Web State of Microservices. Angular World Tour continues this month in Athens and Memphis, and stay tuned for the release of React World Tour. JavaScript Marathon continues in November 15th through the 19th. We're going to continue with our JavaScript Marathon week. Stay tuned for more information. And with that, enjoy Jay Phelps' training on Intro to WebAssembly.
Hi, everyone, and welcome to this special episode of JavaScript Marathon, where we have Jay Phelps, who is going to be talking about WebAssembly today.
Woo-woo, yay! Hello, everyone.
I'm so excited to have a live audience with this. It's going to be amazing. And Jay's just going to blow our brains out with like all the amazing things, right, that you're going to teach us. It's going to be like the best thing ever. And we're going to become experts at the end of this. I have very high expectations.
Right. Yeah.
But Jay, do you want to like introduce yourself really quickly?
Sure. Yeah. I'm Jay Phelps. I'm a co-founder of a company called Outsmartly. But previously, I've worked at a number of other companies, including working with Tracy at This. And I've worked at Netflix and a bunch of other startups and a fintech company, a bunch of other things, kind of gotten around. But for WebAssembly, I've been pretty obsessed with it ever since its initial inception and before with Asm.js. It's kind of precursor to it. For me, I've been a big compiler person my whole life, and it's kind of WebAssembly is a great culmination of all of my passions and things that I really enjoy. So because I enjoy compiler stuff, native stuff, web stuff, add them all together, and that's kind of WebAssembly.
That's exciting. I guess for those of you, for those listening who are like unfamiliar with WebAssembly, do you have like, what's the one website to go to like find all the information about WebAssembly?
Ooh, that's a toughie because there isn't really one website because it really kind of depends on what you're looking for. Like, are you as a person more interested in compiling to WebAssembly, like you're wanting to write C++ or Rust or AssemblyScript or whatever it is, and you're wanting to compile to WebAssembly, or are you wanting to go like really geeked out low level, like I want to understand WebAssembly itself and work on tooling for WebAssembly and all this other fun stuff? I direct you to different places. I mean, there is webassembly.org, and that's kind of the official channel, but it kind of tries to be the end all for everyone, and so it kind of ends up being not the great resource for anyone. There is awesome Wasm. If you Google that, there's a community-based repo that kind of has resources for everything, kind of in like an organized table of contents sort of thing, whether you're looking for tooling or you're wanting to learn the more low-level stuff. Either you can kind of get directed, choose your own adventure sort of thing. That I think is a really great resource. The MDN, the Mozilla and community-based articles are actually getting pretty good as well. They kind of give you a good introduction and all that stuff.
Amazing. Well, this is a Q&A, so I guess we can open it up for questions. Can I pick on Lindsay? Because I remember, Lindsay, you were like saying you had a few questions for Jay or anyone else, really.
I mean, I can go first.
Sure.
The main question I had is, I understand that WebAssembly lets you compile other languages to something that can run in the browser. My main question is, how do you actually do that? Like, what is the process to compile something, either C or Rust or whatever language you want to use to run in the browser?
Sure. Yeah. So it does depend on the language, but generally speaking, a lot of the major languages are getting first-class support for compiling to WebAssembly. But there's details. So like Rust, as an example, is completely first class. Like you don't have to go and get community tooling to be able to compile the WebAssembly with Rust. However, on the C and C++ side, Clang and GCC and all these things, they're working towards being able to compile to WebAssembly, but they're still missing pieces that you need from the community. Something called Mscripten is a tool chain that's built on top of Clang and LLVM to allow you to compile to WebAssembly. The missing pieces are usually related to the runtime related stuff. So if you've ever done native programming type of stuff, usually you have like a C standard library or what have you. You have some sort of standard library. That's the sort of stuff that Mscripten kind of brings that glue code along and helps you out. Eventually, it's going to probably be a long process, but eventually I think Clang will probably ship with all of that stuff built in. But today you still need Mscripten if you're going to do C++ and C. But if you're doing Rust, you don't need that. It has a built-in runtime. And those are just two examples. There's tons of languages. The Go is getting first-class support. AssemblyScript is also really, really, really popular for web-based folks, because AssemblyScript is a programming language that uses the same syntax as TypeScript, so that it can be very, very familiar for folks who are web developers and use JavaScript or TypeScript. It's not TypeScript though, just to be very clear. Like it uses the same syntax, but there are some semantic differences between the languages that can make it a little hard when you're first starting getting used to it, and because you can't, it's not just JavaScript, so you can't like go wild and do whatever you want. But I do recommend, if you've never done C, never done C++, never done Rust, but you still are interested in WebAssembly, AssemblyScript is a really great place to start, because you can have a syntax that's familiar to you while also learning all the new fresh stuff. So if you, so I don't know, hopefully that answers your question. Like the gist is that you'd use some special tooling depending on the language that you're looking to compile to WebAssembly. There's a lot of details that go into targeting the web versus targeting native though, especially if you want to target both. Like if you want to have like one code base that can run natively or it can run in WebAssembly, there's some technical difficulties in related to doing that. It's very almost identical to if you were targeting like Windows and wanting to target Mac. You might have some guards, and you might have some you have some sort of compile time conditionals that decide, do I use this version of the API or this version of the API, depending on which platform I'm compiling on. Because WebAssembly really is, it's you can think of it as a different CPU architecture. So there's like, if you've ever done like low-level LLVM stuff, like where they have like what's called triples, like where it talks about like the CPU, the platform, and the runtime, you have the same problem, because WebAssembly you can envision WebAssembly as just another CPU architecture. And then there's another part of the equation, which is the runtime architect part of it. So what I mean by that is like WebAssembly just is an instruction set. It doesn't dictate how you interact with the outside world. Like how do you log to the console or standard output? How do you read from the file system? How do you make TCP calls? All that information is not like built into WebAssembly. That's platform specific. Like if you're targeting the web, it's going to be different than if you're targeting some sort of other WebAssembly runtime. And WebAssembly has actually been more popular outside of like the browser, as super ironic as that is. Because there's a kind of an inside joke in the WebAssembly community that WebAssembly is neither web nor assembly, because it's not actually specific for the web, and it's actually not an assembly language. It's a bytecode. But yeah, so I wish I could say it's simple, but it's not. There are some complexities involved in using WebAssembly, depending on what platform you're looking to target.
kind of wanted to build off of that and ask, I've seen so many people dipping their toe into Rust, and especially when you're talking about libraries like the bundlers and things like that, switching over to Rust and suddenly getting 80% speed improvements or whatever, hundreds of percent of speed improvements. I guess my question is just sort of, how much do you foresee that penetrating into general web development as opposed to utility and library web development? Like, is this something that you think all React devs, Angular devs, web devs are going to have to know to build performant experiences going forward? Or will this stay mostly in the tooling for a few years?
I mean, for certainly even beyond a few years, I don't think the average web developer is going to have to learn, Rust or C++ or any of this stuff. It's, when you're building low level like the lower level you go in your development, so go all the way to low level to like even developing like the firmware on hardware or kernel level stuff, the lower level you go, the more critical you have to be about performance, because you need headroom for the people who are building software on top of what you're building. Basically, you don't want to take, so if you're writing lower level stuff and you've already taken up 80% of the resources on hardware, that means you only left 20% for people who are building on top, and that's not satisfactory. So the lower level you go, the more critical you are about every single byte of memory, every single cycle of CPU. It gets more and more and more and more critical. So, and they do that, people do that specifically so that when you are writing your React apps in the browser and you've got 1,000 abstractions that go to getting that React app running in the browser, thousands, actually way more than 1,000 abstractions just to get that code running, that you've got enough headroom, you've got enough CPU and memory available that you don't have to be as critical about your resource utilization. So what that kind of means is that it's overkill to be writing like your UI application in Rust or something like that. You're causing yourself unnecessary pain for the most part if you were wanting to do that at this point. That being said, some of these more modern languages like Rust are there's communities working towards trying to make it more approachable, where you can kind of have your cake and eat it too, sort of thing, because we have been, and I think we will be for a while, still to the point of if you want the best performance possible, all the way very nitty gritty sort of thing, it's not as easy as just like, oh, let's write some JavaScript. JavaScript is super simple to write, but it can come at some performance penalties depending on how you use it. Rust has gotten a lot better than like C++ or C as far as like, ease of being able to do things performantly and securely and these sorts of things, but there's still a massive learning curve. Like it is a very non-trivial ask to say, hey, you've been writing JavaScript, now go learn a totally different language like Go or Rust or what have you. And it's not, in my opinion, it's not that these languages are inherently necessarily more complex. It's just that they're different, in my opinion. And that's a very subjective sort of opinion, but I think from my experience you'll get someone who writes Rust their entire life and they've never written a single line of JavaScript, and then they go and try and write JavaScript and they have similar problems. They have similar problems learning it, similar problems using it and doing things performantly. So I don't necessarily think like I don't want to discourage people from, and people feel like, oh, Rust is some like magical thing that's more difficult than JavaScript or something like that. I don't think that's necessarily the case. It's just, it's different. You have different requirements, especially it doesn't use garbage collection. For those not familiar with Rust, it doesn't use garbage collection. It uses something called, what is the term they like to use for it? Borrow checking or
ownership.
Say that again?
Ownership.
Yeah. There's a couple different names for it, but essentially they track the ownership of a particular piece of memory, try to track it at compile time for the most part. Now there's escape hatches to be like, oh, I want to do reference counting or whatever, but majority of your memory is tracked at compile time, and it'll insert the deallocations for you automatically based on the usage. And that sounds great, but it does come with some complexities you have to learn that you're just not used to when you're coming from a garbage collected language. And that's, I think, one of the reasons why Go has been really popular with a number of people is because then you don't have to deal with that. You can just, because Go is a garbage collected language. But it's also, I'm not a, Go is a very interesting language because it, it doesn't have generics. It's going to have generics, hopefully, but they've been saying that for years. So there's, complexities around using Go too. So anyway, I could ramble about that for forever.
There were some comments in the chat. Linda said, all I know about Wasm is that you can use it with Rust to build a game.
There's a tutorial about it. So I'm a complete open book and I have no idea what to expect. Yeah. So Wasm is popular for games, but the primary it's the big reason why Wasm has been popular for games is mostly because there's a lot of tooling for games that expects to be able to target native, not to target web. And so as the native tooling adds support for WebAssembly, a lot of people are able to reuse that existing tooling or code that they've written to be able to target the web. And that's, that's the big thing, is that people don't want to have to rewrite their entire game engine in JavaScript. But if they can keep their existing C++ game engine or Rust or whatever it is they've got and compile that to WebAssembly, then that, is a huge benefit for them, time saver, and be able to reuse that between the different platforms. But it's not designed specifically for games or anything like that. Someone said that they're 100% looking to use how to use Rust to handle WebGL in a canvas. Yeah. So the interesting thing about WebGL is that your shaders and all that stuff. And I'm just to be clear, I'm far from a WebGL expert, but I do have some experience with it. WebAssembly still has some limitations. It's relatively early still in the grand scheme of it, because it is a standardized thing. So it takes some time for the standards bodies to, decide on specific things and get those shipped to the browser and to the various other platforms. But there's something called interface types, which is aiming to allow WebAssembly. Remember how I was saying that WebAssembly is just basically a CPU instruction set, a virtualized CPU instruction set? That doesn't dictate how you interact with the outside world. WebGL being a great example of that. Like how in your WebAssembly binary does it communicate with WebGL APIs? Right now, there actually is no official way. The only way is through JavaScript. Essentially, you could write some JavaScript glue code, or someone else can and have a library for it, that glues your API calls within your WebAssembly binary through JavaScript into the WebGL bindings, the WebGL API. And that has a cost. That cost of going through JavaScript to call these bindings has an unfortunate overhead. It's gotten better in certain browsers. Firefox in particular has done a good job at optimizing that bridge, but it still exists. There's still a cost to that API call. And so WebAssembly is not a hammer that unfortunately a lot of people wish it was, in the sense of it's really, really great for doing computation that does not leave the WebAssembly binary. So if you're just using WebAssembly, you're computing numbers, those sorts of things, it's really great for performance. But as soon as you need to leave that WebAssembly and call into JavaScript to call WebGL or call an AJAX request or any sort of IO or anything like that, you can see some performance hits, especially compared to the equivalent JavaScript that you might write. And what that ultimately just means is, if your application is IO bound, meaning like you're trying to optimize the performance of these API calls through something, whether it be WebGL or Fetch or any other IO, it's probably not going to be the best solution, because it'll actually be slower than what JavaScript would have done to begin with, because you have to cross that bridge. You have to convert from whatever representation you have in WebAssembly to whatever representation JavaScript is expecting. And then it gets further converted once you give it to the native API like WebGL. It has to get converted to then whatever representation it's expecting. And so if you had just stayed in JavaScript the whole time, sometimes it can be actually better performance, as counterintuitive as that is. Part of that is just because of that lack of interface bridging that the standard body's working on. But also part of that's just JavaScript has been optimized for many years, right? We have a lot better optimization or infrastructure in place on JavaScript related stuff than we do on WebAssembly still today. But once interface types, which is that proposal will allow WebAssembly to be able to call these APIs directly without having JavaScript act as the intermediary. And it will also give programming languages an official format that it can use to communicate with these. So like one example that hopefully I can explain it simply, but it's actually a very complex problem, is that strings are not represented universally. Like how a string is represented in memory is very language specific, and not just language, sometimes even platform specific within the language, like whatever platform you're targeting, it changes. And so strings can be a source of performance degradation if you're needing to convert between different types of strings, UTF-16, UTF-8, and all sorts of other problems that can come with that. If you have to convert between all these things, you're looping through every single character and doing conversion. So if you have a big buffer or something like that, that can be the source of performance issues. But interface types is hopefully, fingers crossed, that the proposal can figure this out, going to give a more official universal language for interfacing with either other languages or APIs native to whatever WebAssembly platform you're running on, like the browser. And let's see here. Trying to do introductory things to Rust. Can we use WebAssembly to run machine learning models faster in the browser? It depends on, machine learning stuff is also another thing that is not my forte, but I have some experience with, but it's not my specialty. But it really comes down to how the machine learning works. Like, does it use GPU related things, or is it all just on the CPU? If it's all on the CPU and doesn't require crossing that bridge into JavaScript or any other language, absolutely, WebAssembly can give a performance boon. I know that there are several implementations of various machine learning stuff that saw a significant performance improvement moving to WebAssembly. That being said, not all of them would. I mean, I would expect to see that there are some that are written in ways that don't optimize as well as the JavaScript stuff. One thing that I think is disappointing to some people is that comparing WebAssembly to JavaScript is difficult because JavaScript uses just-in-time compilation. And what that essentially means is that while the JavaScript is running, the virtual machine that is running it is kind of learning about the patterns in your code. It's learning, oh, you've called this function 1,000 times with the same types of arguments. You've called it with a 32-bit integer every time and a string. Every single time you've called it that way. Well, guess what? I can optimize that function. I can make a copy of it and expect these certain arguments and do some optimizations around that to get speed up. That's what the virtual machine would do automatically under the hood transparently. And because of it's doing these sort of just-in-time optimization tweaks and stuff like that, it can be really kind of hard to compare JavaScript to WebAssembly because it really depends on the code you wrote, because there are pitfalls to JavaScript. Like one wrong move in the way you wrote your JavaScript can cause the virtual machine to be like, oh, I can't optimize that. And they call that a deopt. So it would deopt, and basically it's like, oh, I'm not going to optimize that function and it's going to run slower. And that's a very non-obvious thing unless you're looking at the bytecode that gets generated or you're doing really low-level profiling. And so it can be really difficult to make a general statement. Is some JavaScript going to be faster or slower than some WebAssembly? Because it really depends. You can write JavaScript that actually will be faster than the WebAssembly equivalent. But I would say, on average, as long as you're not using, again, I/O bridges and you're not making external API calls, if you're just computing math-based things or doing string manipulation, WebAssembly on average is going to outperform JavaScript, but not always. Let's see. Is there anything you need to keep in mind when using different languages or tool chains to compile to WebAssembly, or do they all provide pretty much the same end product? Let's see. Yeah, it's a tough thing to answer. So it really does depend on the language. The level of support, the level of documentation is a big one as well. And also what sort of projects you're working on. Like, so let's take it, we'll compare a couple examples. There's three major, there's tons of languages that are working on compiling to WebAssembly, but there's still three major ones that most people use, and that's C or C++, which I'm just gonna put them in the same category, Rust, and assembly script. And all three of them have some way of calling to the outside world, like making bindings to either JavaScript or whatever language you're trying to compile or trying to interrupt with. Like if you're I'm one of those people who sometimes can be a little too pedantic in the sense of it's tough for me to talk about WebAssembly because it really depends on the platform. Like, so a lot of people will generalize and say WebAssembly, JavaScript, right? But that's assuming that you're targeting WebAssembly to the browser. What if you were targeting WebAssembly to Wasm or one of these other WebAssembly virtual machines that have no concept of JavaScript? Like they're not a browser. They don't actually have JavaScript at all. And so if you were trying to interrupt with that environment, it's very different than if you were trying to interrupt in the browser. But setting that for aside a second, because that just complicates the discussion, I'll just talk about JavaScript. And if, so that's one of the big things you want to keep in mind is most likely you're going to need to call to JavaScript to do various things, to make API calls or what have you. So knowing how that works would be probably one of the first things. If you're going to use WebAssembly for the web, I would actually try and figure that out first, just to see how intimidating is it, how easy is it for you to use, what's the documentation look like on that. Like mscripting with C++ has something called mbind, and as a way to be able to call out to JavaScript. On the Rust side, it has something called Wasm Bind Gen. Bind Gen is one word, and it's binding generation. That's what Bind Gen is short for. And it's actually I would say out of all the tooling, Rust kind of has some of the most impressive tooling. Part of that is kind of cheating in the sense of Rust has a really great macro system. Basically, it's able to at compile time generate code, and the macro system makes a lot of things really simpler and easier to use. And it also has like a really great annotation system as well. So Wasm Bind Gen is how you, in Rust, be able to bind to external things like to JavaScript to be able to call out to those things. So that's the biggest thing that I would keep in mind, because it's different depending on what language. And another thing is community tooling. Anytime you choose a language, in the top 10 things you need to pay attention to is what does the community what does the community look like? What is what libraries can I use that are going to be compatible with WebAssembly and compatible with targeting the web? Because some libraries are going to be written specifically for specific CPU architectures, or even worse, specific APIs. Like it's assuming that, there's an API that I can use that just doesn't exist on the web. There's also something called WASI, W-A-S-I, which is in combination with the interface types trying to solve the problem of, for those of you familiar with POSIX, like it's like the Unix infrastructure for like, how do I communicate with the outside world? It's trying to basically solve the similar problem where it's like, let's create a standardized interface that WebAssembly can use. And then that interface will then smooth over the problems of what platform am I on? Am I in a browser? Am I in Node? Am I in Wasm? Wasm is a community virtual machine. There's a lot of WebAssembly virtual machines, and WASI the goal of it is to kind of smooth over those API differences. Got another question. What considerations need to be made for browser support, or do Safari, Chrome, and Firefox all support the same WebAssembly standards? They all the modern browsers support WebAssembly, but it is true that what features of WebAssembly varies depending on the browser. Traditionally, Chrome has led the way in browser support for features. Firefox has been pretty close in various times. Sometimes Firefox will have things that Chrome doesn't, but Chromium-based browsers have typically led the way, especially if there's a buttload of features of that WebAssembly, the community group, has been working on that have not yet been unflagged, but and Chrome supports a good number of them. So so how do I say this? WebAssembly is kind of a unique beast in the sense of there's no one out there right now trying to standardize like, oh, the Bluetooth APIs or a file system API or something like that. Like that's outside of the scope of WebAssembly, unlike JavaScript. So you have a lot less you have to worry about when it comes to that. Like you'd still be calling the JavaScript Bluetooth API. You'd still be calling the JavaScript file system API. So if you need those APIs, then you just have to look up the JavaScript support. But the things that WebAssembly varies on depending on the platform are things like the atomics related stuff for like whether you can do multi-threading. There's the, let's see, let me pull up some of the proposals because I'm having a hard time remembering. WebAssembly proposals. There's a bazillion of them. Oh yeah. So SIMD is one of them. SIMD. It stands for Single Instruction Multiple Data, and SIMD is used for doing true parallelism at the CPU level. So it's for if you had like a vector, if you have like an array of data, not like a JavaScript array, but like an in-memory representation of data, and you want to perform the same mathematical operation on multiple slots within that, like let's say 128 items in the array, you want to perform the exact same operation on that. Well, SIMD is an instruction set that allows you to do that, to do 128 operations on the same on a set of data in parallel, and it's CPU specific, like what's because there's 128, 256, there's different sizes that you can do, but WebAssembly aims to smooth that over and just kind of support a standardized instruction set for that. And let's see, what's another one? There's the GC stuff, the garbage collected stuff. So one of the things that has kind of held back WebAssembly on some things like Go and Elm and Rescript, which used to be called Reason, and Dart and these sorts of languages, is the lack of interoperability with the built-in garbage collector of JavaScript runtimes. So let's say you're trying to use Dart, and if you're calling the DOM APIs, that's a garbage collected reference, right? When that garbage collected reference needs to go over to WebAssembly, there's not an easy way of actually doing that, because for very technical reasons, they have to be very careful to not expose underlying implementation details that are not specified in any spec, and also for security reasons as well. So there's been work that's it's still possible to do your own garbage collection, and that's what Dart and Go and some of these other languages, they have an implementation, but it doesn't perform well because of some very technical reasons. And so there's been a huge amount of work to try and figure out, well, how can we represent these? Like, how can we first off give languages a really great hardened garbage collector that they can piggyback on, so they don't have to send a megabyte of WebAssembly bytecode just to have a garbage collector, but also interrupt with the existing garbage collector. And so there's been work towards that. It's unfortunately, as most things in software and specifications go, everyone knew it was going to be really complex, and it ended up being even more really complex than really complex. And so it is kind of, that proposal has dragged along and kind of had a lot of different variations. And so it is still unclear when or even if we're going to get something. I think it's pretty likely that we'll get something within the next 5 years ish that will allow languages like Dart and Elm and these to perform much better. But I think that that's one thing that has prevented WebAssembly from going mainstream within the browser, is just the lack of good garbage collection support, because most people don't want to manage their own memory, and they don't want to learn borrow checking and all these other things. They want to use a language like Elm or Dart or Reason or Rescript, or some new language. I think once WebAssembly is a great target for garbage collected languages, which is not today, but once it is, I think there'll be an explosion of more languages that are targeting the web specifically. And are much more along the lines of like assembly script, where it's much more familiar, but yet it fixes some of the mistakes, quote unquote, of JavaScript. And really, it's like, developing a language is such a hard thing, because it's hard to have foresight into the future and patterns and trends and what sort of things. So it's really hard to fix a language like JavaScript. There's a lot of cruft, for lack of a better word, that you just can't fix, because you've defined it and people are using it a certain way, and you just can't break it. And so new languages offer an opportunity, at least, to experiment and try and resolve some of those mistakes of the past. And I'm a language nut, so that's kind of my biggest excitement about WebAssembly in the long run. Let's see, got another question. You mentioned that WebAssembly is often used outside of the browser. What are some of the use cases that a newcomer to WebAssembly could try out? One part is smart contracts. WebAssembly is unique in the sense of there's never, as odd as it might sound, there's never been a truly community-based standardized bytecode ever specified. Like no, it's never before have all the major companies come together and said, let's make an instruction set and actually decide on it together. Intel developed in a box, ARM developed in a box, all these instruction sets, Java bytecode developed in a box, the CLR, like the .NET stuff, developed in a box, and they're all, variations of proprietary. I mean, there's some things that are like kind of not proprietary, but by and large, they've all been developed in a box by relatively a sole entity. Whereas WebAssembly, all these major companies came together and designed it together, and it's open and not owned by any one particular company. And so it offers a really unique opportunity for other situations that the standards body knew but didn't quite realize to the full extent. At least I don't recall it being to this extent. Like the smart contract stuff, the people wanting to, WebAssembly offers an instruction set where it's like, well, there's a lot of virtual machines now being written for WebAssembly. I can actually use that virtual machine and just add some sugar on top of that to control like what they call gas or any of their resource allocation recording. And so that's one example of outside the browser. Another thing is people who want to run untrusted code. It's a really difficult security problem to run code for people that you don't trust. I'll give you an example of Shopify. Shopify has a platform for their enterprise users to be able to inject Ruby code into their infrastructure and run their some custom Ruby to change like, custom discounting or custom workflows and all sorts of fun things. And so they set out, well, not everyone wants to write Ruby, right? So they set out, how do we solve this problem in a way where other people can use other languages? And WebAssembly gave them an avenue to do that. And they have a WebAssembly virtual machine that they've kind of bolted into their existing Ruby infrastructure, and they're able to then run unsafe code within the WebAssembly virtual machine, compiled from any language. They're primarily targeting assembly script, like primarily with their tooling and stuff. But in theory, you could use any language you want that compiles to WebAssembly. And that is only possible because WebAssembly is an inherently it is an inherently sandboxed virtual machine and environment. I was gonna say memory safe, but it's really not, because it really depends on the language. There's there's a whole class of security bugs that WebAssembly makes impossible. Like as an example, traditional Stack Overflow, inject some of my own custom code and then jump to that. Like that's a really, really, really common security exploit of like C and C++ code. That's not possible within WebAssembly. It's physically impossible. You could, and then that's just by design of the way the instruction set actually works and how memory is laid out and isolated. You can't inject code and then just run it. It's just not possible. And so that's a really attractive trait. It doesn't prevent all classes of bugs. Like you could still inject a function index, like a pointer, for example, that you want to, like if you could trick the system into putting your own function pointer in a different place in memory, and then something calls that function pointer indirectly, like an indirect call, that would still be an exploitable thing. And so it is still important to do some level of being cautious about security, but it would only it would definitely limit the blast radius. Let's see, what other use cases outside the browser? I would say this hasn't really taken off per se, but there is definitely, in a similar vein, there's a class of people working on tooling to be able to use isolate libraries using WebAssembly. How do I explain this? You know how in the JavaScript ecosystem, where there's a very common pattern, and it's oh, I need some library to do X, Y, and Z. So I go to Google or I go to npm and I search for X, Y, Z. I see a library and I just run npm install and I just say, woohoo, great, awesome, I'm now using your library. Now I didn't audit your library. I have no idea whether it contains exploits or naughty code. I'm just trusting you that you are not a bad person. And we've gotten away with that by and large just because developers are good people, I guess, or don't want to lose their career. But there's a class of people who are working on like in the native world where it can be more important because it's outside of the browser and you have access to more stuff. It can be more important to be very careful about the libraries you're using. So there's tooling around being able to use native libraries isolated through a WebAssembly virtual machine, so that you can get good performance, but any of the library code that you're using can be isolated, and you can basically say, I want to give it access to this directory and this IO, but I don't want to give it access to anything else. So it can't, go off and arbitrarily start reading from your disk or any of that sort of thing. That's another use case. There are people who are also using WebAssembly on the server, like just as a way of adding yet another layer of isolation. So if an incoming request were to try and exploit the web server, it would still be inside the WebAssembly virtual machine and have the security benefits. And so it's far less likely that they'd be able to escape out of that and get even lower level access. The next question is about Blazor. Besides Blazor, are there any examples of front-end UI frameworks using WebAssembly? There is, so Qt or Qt, whichever way you want to pronounce it, Qt does support WebAssembly. It's a traditionally Linux-focused UI library, like widgets and stuff like that. It supports it. I mean, it's one of those, like, if you really knew how it worked, it's kind of one of those like, but why, like, sort of things, in the sense of like you're shipping a lot of code to just use Qt. So I don't really recommend that. But by and large, there isn't any that have really taken off. There's no like really, really popular ones. And in my opinion, there's a good reason for that. And that's that you wouldn't really want to write your whole UI in a language and then compile that to WebAssembly currently, at least in the browser. On native, it might be viable, but there really isn't, that it really isn't a common popular thing at this point, just because it's like, if you're writing your own app, there's not a huge reason to compile. Like if you're writing a native app, I mean, like an iOS app or a Windows app, there's not a huge reason to write your whole, to compile your entire application to WebAssembly today. So I would still recommend using native. Now on the browser, you have the problem of any UI library or anything you compile has to get shipped to the browser. And a lot of these traditional native UI libraries are fairly large in file size. You don't want to be shipping megabytes and megabytes and megabytes to the browser. That's just not viable. And then you have the problem of performance. Anytime you need to interact with the UI, you have to cross that bridge into JavaScript land, and then that JavaScript land has to call into the native API, the WebIDL API. And so it's just not, you don't usually write a UI application in C++ or Rust and then compile that to WebAssembly. It's just not a thing that you would typically do, at least today. In the long, some of those other proposals, interface types, garbage collection, and WASI, there is a future potentially, and I don't want to overpromise, but there is a potential future where if we had all of these things and then some, languages like AssemblyScript or Elm or Dart or what have you could more natively interact with the DOM or Canvas if that was your bag. And in that world, then it might be much more viable to write a full-fledged UI application in another language without targeting WebAssembly. Today, there's a reason why Dart and Elm and these still compile to JavaScript. And that's just that performance of the bridge and the garbage collection related stuff. And that based on the progress that the proposals have made, that'll probably be that way for at least 5 years, if not 10 years. Like the spec proposals can move really slowly. And that's good because we would rather not, at least for me, I would rather not have the wrong thing. I would rather wait and have the right thing than have the wrong thing and be stuck with it for the rest of our lives, because that's what anything we put in WebAssembly and especially if you put it in the browser, we're stuck with it. It's really difficult to change and break anything in the browser. But Blazor, it was that example that he mentioned or he or she mentioned, and that was one of it's somewhat popular. It's again, similar problems. It's cool, but it definitely suffers from performance. It's if you're trying to write an app that performs really well, Blazor is probably should not be your first choice. Unfortunately today. Someday, like I can definitely see a future where people are using like Flutter. Flutter is definitely working on a WebAssembly port. But it will be a while before it will be performant because of those missing proposals that I was mentioning. So front ends are not great use case. What would you say are examples specifically for the web and web apps where this really shines? It really shines, I'll oversimplify and then kind of unpack. It really shines anytime you're wanting to do a bunch of math, which sounds like, I never do math. Why would I ever want to do that? That's not actually true in a lot of cases. There are a lot of things that can be ultimately distilled down to a bunch of math operations. Anytime if you were going to use the word parse in any way, any kind of parsing is usually really great and performant use case for WebAssembly. Ultimately, it comes down to how long can you spend inside the WebAssembly virtual machine without crossing the bridge into JavaScript. The longer that answer is, the better and more likely that WebAssembly is going to be a great use case for you. So if you're trying to, I'll give a couple really great examples. Image optimization or any kind of image manipulation is a phenomenal example for WebAssembly. It can, in some cases, beat the pants off of JavaScript in a tremendous amount, because it ultimately does distill down to a bunch of math related stuff under the hood for doing all that. And so, yeah. Image things, video things. Let's see. If you're trying to do like a bunch of parsing, if you had like a streaming parser that needed to parse some strings and do some crazy manipulation and then ultimately, produce a representation that you can use, that's a really great example. Let's see. If you're trying to port an existing, there's a ton of existing algorithms for doing various things, like whether it be I'm trying to think of some algorithms that are actually common because there's so many, But anytime you're trying to do some sort of algorithmic sort of thing, which again, kind of is just a different take on math, WebAssembly is really great for that. But yeah, case in point, if you're the average, if you're an average JavaScript developer writing a React app, frankly, you're not going to use WebAssembly in most apps. And it's just the way it is. And I think it's a good thing to admit that, so that people aren't reaching for something that's a premature optimization that's just going to make your life harder. Because there is complexities that come with using WebAssembly. That being said, there are a number of libraries that you might end up using where it uses WebAssembly under the hood, and it's kind of an implementation detail, and you don't really need to even know it. So if you, that's not, it's not super common at this point, but I have come across it, and people do use it. Interesting enough, you already probably are using WebAssembly without realizing it, just not in your UI code, but in your build process. Several of the tooling things within the JavaScript compiler ecosystem use WebAssembly. The source map package for generating and parsing source maps uses WebAssembly, case in point. But yeah, it is true. If you're writing just a typical React application, you're probably not going to want to use WebAssembly at this point. It's not going to buy you a whole lot. The next question, what does interop look like from the JavaScript side? Are you basically just invoking an imported function? Yeah. Actually, interop is very similar to most foreign function interfaces, where you are you can define, like, I want this function to be available to the outside world, and then when you instantiate the WebAssembly module, you get an instance of that module, and that instance has an exports object on it, and then the exports it's just an object that has the functions that you have exported from that WebAssembly module. And you can call it just like you call any other JavaScript function. Sort of, I guess I should be more specific, that like you can call it like any other JavaScript object, but passing things into it become complex, because you can't just give WebAssembly a JavaScript string or a JavaScript object. It doesn't know what they are. It's like, what's a JavaScript object? I don't know what that is. It's this opaque thing that it cannot introspect by itself. It can't look inside of a JavaScript object. And the reason behind that is that WebAssembly is more lower level. So if it were able to do so, it would just be looking at raw memory, and that would be a security issue. And so the WebAssembly virtual machine will not allow it. It essentially can only cross the bridge as this opaque thing. It can pass around that opaque thing. It can be like, oh, I've got a JavaScript object. Would you like this JavaScript object? I don't know what it is, but would you like it? Like, it can pass it back and forth and give it back to JavaScript, but it can't introspect it by itself. Now that sounds very limiting, and it is, but there's other things you can do. Just because WebAssembly itself cannot introspect it doesn't mean that you can't introspect it. WebAssembly itself can import functions. So it can import reflect.get, which is a function provided to JavaScript to be able to look up properties. Like you can use it to look up properties on an object. So it can import these functions and then say, well, I want to look up this field of this object. Okay, so it looks up that field of that object, and now you've got whatever value was at that object, was at that field. WebAssembly still doesn't know what that value is. It's still opaque to WebAssembly, but it is able to look it up, right? Like if you use these external functions that you imported, reflect.get and stuff like that. So I know I keep saying it, but it's complicated, unfortunately. There's a lot of things that we do take for granted as JavaScript developers. Now, the things that I'm kind of talking about, I'm talking pretty low level. The ideal is that languages totally just gloss over those problems, like they pave over those problems so that you don't have to know about them. Rust, as an example, does a pretty phenomenal job at paving over that problem. Like it has first class types to represent JavaScript objects, and there's ways, like when you're writing Rust code, you don't have to worry about the fact that WebAssembly itself actually technically cannot introspect a JavaScript object. It allows you to introspect it as if WebAssembly is able to, but it's not. And so it smooths over all of those problems. But unfortunately, that's a very language specific thing, like how Rust does it, assembly script, C++, etc. Is very language specific. Any other questions? Otherwise, I can maybe touch on some other random information about WebAssembly. Cool. Yeah, so one of the things, thanks, Lindsay. I appreciate all your questions. They've been great. Someone was jumping off. One of the things that I think is super, super common with people is that people want WebAssembly to be something it's not, and then they kind of get disappointed when they find out. And that's like, we all really, really wish that there was some way to make our code fast. And WebAssembly does offer an avenue for certain classes of code and type of use cases, but unfortunately, it's not a silver bullet. And so the big disappointment comes that you can't just throw any problem you want at it and it will be faster. In fact, a lot of cases, it will actually be slower. And so you unfortunately need to learn a lot of nuance about WebAssembly to really understand whether it's going to be a performance benefit or an actual not a benefit, a negative. And so there's there's some general things that a person can say, like about the math stuff being faster, but not a silver bullet, unfortunately. I think the other thing I wanted to touch on, which I'm actually surprised no one asked, is WebAssembly going to replace JavaScript? It's a very common question and a legitimate one, I think. And generally speaking, no, there's certainly no plans to replace JavaScript. And I think even if we had a phenomenal language that was attractive to people who would otherwise write JavaScript and compiled to WebAssembly, I think JavaScript will, for a really, really long time, 20, 30, 40 years or what have you, I think still be the dominant language written for the web. And if anything, it's simply because it's built in. How do you be built in? You don't have to ship a runtime. You don't have to ship your garbage collector. You don't have to have compile time tooling, any of this stuff. You can just throw a script tag on the page and you're off and you're starting to write. And I think a lot of people don't realize that a vast majority of people writing JavaScript for the web, it would be a very big pain in the butt for tooling to get there to be able to make the experience and the performance of JavaScript for writing any arbitrary thing, like sprinkle some JavaScript for some click handlers on your page sort of thing, which is what most people are doing. I don't think WebAssembly or any language that compiles to WebAssembly can get there, at least in some short amount of time. Now, maybe someday there'll be some way of like shipping additional runtimes to people's browsers, and so it will increase the performance, and so you don't have to download as much code and stuff like that. But we're ways away from that. So I think if it depends on, some people ask because they're worried about their career. Some people ask because they want to make sure that they're focused on the right language, like when they're learning. But I would say a majority of people ask just because they wish that JavaScript would be replaced by something else. That's just not going to happen. And I think languages like TypeScript, I think, are really great at kind of solving some of those problems of some of the mistakes of JavaScript's past and those sorts of things. But I do really confidently think that there is a day, we're not there today, but I think that there is a day in the future where serious complex applications will be written in another language other than JavaScript. Like on average, like most applications write in a different language other than JavaScript. We're already kind of seeing that huge explosion, not with WebAssembly, but with TypeScript. TypeScript used to be such a bespoke, niche thing, but today a lot of jobs are now requiring TypeScript, and I think that's a clear indication that there's appetite for static type checking and better better tooling around those sorts of things. And so I think once WebAssembly is ready for those sorts of use cases, I think it's only a matter of time. How are we looking on time, Tracy? You're muted.
Yeah, we have like another 20 minutes or so.
Okay, great.
Yeah.
Awesome. I didn't know. Yeah, if anyone has any questions, feel free to drop them in. I'll start looking around for some topics that I might want to talk about that are interesting. For those not familiar, so because I threw around a lot of terms that maybe are helpful to unpack, like bytecode as an example of a term. A bytecode is essentially a word that represents a binary instruction set for a virtual machine. Virtual machine meaning a machine CPU that doesn't actually physically exist. There is, today at least, there is no physical WebAssembly CPU that exists, no CPU that can run WebAssembly natively. And so WebAssembly is a bytecode, meaning it is an instruction set in binary for a virtualized machine. And so what that ends up meaning is that once you've compiled to WebAssembly, it's this binary file that is pretty much impossible to actually read by hand because it's just binary, right? Like there's no rhyme, there's a specification that dictates it, but there's no rhyme or reason for a human to be able to understand it. So instead, there's a textual representation of WebAssembly called WAT, W-A-T, like what? That you can use if you ever need to debug the actual WebAssembly instruction set, the output itself. It's a little intimidating at first for folks because it's low level stuff, but I think it is interesting. I enjoy looking at those sorts of things. Let me kind of poke around a little bit. All right, I'm going to Tracy, is it possible if I could share my screen?
Yeah, give me 1 second. Let me go ahead and enable it.
Sure.
Okay, go ahead.
Nice. All right. So this is my old resume. I haven't updated it in a number of years, but I'm not showing my resume because of my resume. I'm showing it because for fun, I wrote this. This resume is generated using WebAssembly text by hand, and so I wanted to kind of poke around in this and kind of show folks like what it would look like if you wrote WebAssembly text by hand. Now, as a reminder, this isn't really WebAssembly in the sense that WebAssembly is a binary representation. This is a textual representation of that binary. So this text gets compiled to the binary, but it still gives you a pretty good gist of what it kind of looks like if you were to write WebAssembly by hand. You can see we've got these parentheses. If you've ever written Lisp, this is what they call S expressions. And this is just one representation of writing WebAssembly by hand. Maybe just a little,
yeah. Thank you.
Is that good?
Yeah, perfect.
Cool. Let me see if I can get even further. There we go. We'll keep going. So here we can see I have some imports, right? And we've got like the namespace and then the name of the thing that we're wanting to import. Here we can see I've got like environment object.get, environment object.set. So I'm saying I want to import these functions. And this is where I was saying about how WebAssembly itself it doesn't know what a JavaScript object is. It's just this opaque thing. But if you import functions that do know how to use JavaScript objects, then you can actually call those functions. Like here, I'm using this to say object.set, and we've got like I create an element and I set it in a local variable. And then I have some text constants I have for inner text string. So if I go to inner text string, just passed it. This is saying there's a global called inner text string, and it's a 32-bit integer, and it is at the offset of 55 within the linear memory constants. That is probably pretty intimidating, but the gist is that we have I've hard coded some strings in here, and the 55, that would have been right here. So here we can see there's that inner text string that I had hard coded. And that allowed me to make a variable for that so that I could say object set. I basically am creating a div and then setting it on a local variable and then setting the inner text string as the Wasm banner text, whatever that text is. And I do similar stuff with this class name. I have append child right here where I create an anchor element, and then I append it into there. Pretty low level, but at the same time, I think once you would learn the very basics of like what's a get local and what's a global and all that fun stuff, it's not too bad. Here I'm creating the header. Let's see, I'll scroll down a little bit. Yeah, so a local, so a WebAssembly, and by the way, if you're using WebAssembly, you don't have to go as low level as this. The idea is that you're using a higher level language and compiling to something like this. But I just thought it would be fun to kind of show some of the lower level stuff and demystify it. WebAssembly itself is what's called a stack machine. And that essentially means that instructions are evaluated on a stack. So like you push instructions on the stack, and then the machine will pop them off, including the operands, the arguments to functions. You put it on the stack linearly, and the machine will pop them off the stack and then execute it. That being said, it also has the concept of locals, which are, if you're familiar with native stuff, they're equivalent to registers. Like WebAssembly has like an unlimited number of registers called locals, and whether they actually map to a real register depends on the actual machine itself, like whether the machine has enough registers to be able to store all your locals. But they're local variables. From a JavaScript point of view, you can think of it as just a local variable. So you can see here, set local is just setting a local variable. So I'm creating an element, an li element, and then I'm setting it to the li local variable. 32-bit integer. And you'll notice you're not seeing any actual string types or element types or any of that stuff. All you're seeing are 32-bit integers, 32-bit integers, 32-bit integers. And that's again because WebAssembly doesn't have any concept of JavaScript or the DOM or any of that stuff. It just has the concept of numbers. And so you can kind of think of this as like pointers. Like this is essentially a pointer because I've got this glue code. I've got this glue code that I've written in JavaScript. So there's the JavaScript import that I gave it, document.createElement. So for a given string index, I will look up the string based on the index. So I've got the heap, the linear memory where everything is stored. The string index is essentially a pointer. I'm saying, here's a pointer to that string. Now look it up. It will look up that string in JavaScript, in the JavaScript land, create an element using the JavaScript API, and then it will add it to what I called here the shadow heap. And essentially that's because in WebAssembly, because I can't represent this HTML, I can't represent that HTML element as an actual thing, I instead have this kind of like side heap map where I set the value and then I just increase this pointer. So instead of passing around the element itself in WebAssembly, I'm actually just passing around a number that represents a location inside of this map. So that way I'm able to look it up when I do need it. But in WebAssembly, I'm just passing around numbers. I'm just saying, hey, here's the location of that element. I don't actually know what the element is. See if there's anything else interesting inside here. It's all pretty much the same thing over and over and over, right? I'm just creating elements and assigning classes and what have you. Yeah, I think that's pretty much it. So I'm not going to go further on that. Let me look inside the runtime because that's somewhat somewhat useful. So here we can see there's an API called Instantiate Streaming. Safari used to not support it. I think it actually supports it now. I'd have to double check, but because it's been a hot second since I've had to care about Safari. But you can pass in the the response for the WebAssembly module in a streaming fashion. And so WebAssembly will be able to compile, or the virtual machine can compile the WebAssembly as it's streaming in. It doesn't have to wait for the entire binary to be downloaded. It can compile it as the binary is being downloaded, which can give you a really great performance benefit. And then once we've got that reference of that instance. And there's where I was saying that it's got exports. So this is the main function from this file. We're just calling it. So if I go and search for main, we're going to see here's that main entry point that I said that I wanted to export. This is the entry point of the application. So I create the Wasm banner and I append that into the body. And then I create the resume and append that into the body as well. Those are the two sections in the resume. It's made up of more stuff. So, so someone said, so this is kind of like writing x86 assembly or something for a specific architecture, but for WebAssembly. That's exactly right. Yes. Yeah. So WebAssembly is just another CPU instruction set that's generic and not specific for the web. But then it's up to you, just like if you were writing assembly by hand, it's up to you to be if you were writing WebAssembly by hand, it's up to you to be cognizant of the underlying APIs that you need to be able to write. You have to, import and export and know what the ABI, the application binary interface is to communicate with these things. If you're using a higher level language, which hopefully you are, and you're not writing WebAssembly by hand, because it's, just as writing WebAssembly by hand is just like writing x86 by hand. Very few people do it. Unless you really, really, really need to, you try and avoid it. But it's fun, I think. So if you're writing higher level, the goal is that the language will abstract away those platform differences for you, just like they do when you're writing an iOS app or a Windows app or what have you. Someone asked, does it output that type of code as a file and then compile that down to bytecode? Some languages do. Some languages do use the textual representation as an intermediate format, but all the major ones do not. Like C++, the mscript and toolchain, and the Rust and AssemblyScript all go to WebAssembly binary directly without going through an intermediate textual representation. There are a lot of, I'm going to share my screen again. There's, if someone is interested in the lower level stuff, there's a lot of tooling on WebAssembly. Couple of them of note is Wabbit, which I love saying some of these names. Wabbit is the WebAssembly binary toolkit, and it has things like WebAssembly to Watt, like Wasm to Watt, which is it will convert the binary version to the textual representation. And then it also has a utility for doing the opposite, converting the textual representation to the binary representation. It's got ones for dumping. It's got for desugaring. It also has a really cool one. This is pretty neat. WebAssembly to C. So if you have a WebAssembly file and this thing will convert that WebAssembly file to actually a C text file. And then you could take that C text file and run it through any compiler of your choice to compile to some other platform. That sounds like a really great silver bullet, but keep in mind that it doesn't solve the application binary interface and API problem, in the sense of if you're trying to call an external API, like any kind of IO whatsoever, this is not going to solve that problem. Like, you can't use this to compile it to iOS and it will somehow magically know how to communicate with UIKit or Cocoa or any of these other APIs. But it is really cool for if you wanted to basically make an ad hoc virtual machine without an actual virtual machine. Like, so let me see if the description. Yeah, it doesn't actually describe it very well, but the gist being is, remember how I was saying that some people are trying to use WebAssembly as a way of using native libraries in a secure fashion? Well, you could use this to do that. If you had let's say you've got a library that is compressing some images or something like that. And you wanted to use it in your native app, but you didn't really trust the code, and you wanted to be careful, or even if you did trust it, you didn't want it to be a source of exploits. Like maybe you're afraid someone will exploit that library and then exploit your own app. Well, you could compile that library to WebAssembly, and then compile the WebAssembly to C, and then compile the C to whatever, toolkit you're using. And by doing so, it creates kind of an ad hoc virtual machine, in the sense of you don't need a full-fledged virtual machine. It's already ahead of time been compiled to C, so it can be kind of ahead of time compiled to native code, if that makes sense. It's kind of a inception sort of mind melting sort of thing. The other thing is Binarian. Binarian is used, it has some tools. Let me see if I can find some of the tools here. Here we go. So it's got Wasm optimization. So Wasm opt, WebAssembly, the Binarian is like a toolkit for compiler authors mostly. So the optimization tool will run its intermediate representation passes and do optimizations to the WebAssembly, like constant folding and removing dead code and these sorts of things. It's got, let's see, that's the textual one, unassembles. It's also got a WebAssembly to JavaScript tool. And this only works with the original specification of the WebAssembly stuff, but it's still really useful. So this could be used essentially as a polyfill, not literally a polyfill, but in the sense of if you, let's say you have a binary and you need to run this in Internet Explorer 11. You could use this tool to compile the WebAssembly to JavaScript and then run that in Internet Explorer 11. It's not going to perform very well, but at least it would work. And then it's got a couple other things for like shells and stuff. But Binarian is mostly used for its IR, for its intermediate representation. It is what like assembly script uses it to compile its stuff to WebAssembly. The language Grain uses it to compile to WebAssembly. One of the current forks of the Go compiler, it's not listed here, but one of the forks of the Go compiler uses Binarian to compile to WebAssembly. It's a pretty cool, popular tool chain. All right.
I think probably wrapping up now. This has been so informative.
Cool.
I remember, Jay, the first time we talked about WebAssembly, I was like, oh my God, WebAssembly. And you basically convinced me that as a JavaScript developer, I didn't need to know about WebAssembly.
Oh, sure. Yeah. Do you remember, Tracy, when we were at Netflix and I taught you how to make, we made
Yes.
We made Baylang. Yeah, we made a programming language called Baylang that compiled to WebAssembly. I was teaching her about WebAssembly by making a new language, and compilers by making a language.
Yes.
It was,
I think that was like a 3-hour Saturday at Netflix hanging out. I'll never forget when you taught me about prototypal inheritance, though.
Oh,
when
wow.
I don't want to know. I was like, Jay, come on, don't tell me. I didn't need to know about prototypal inheritance, Jay. He's like, you do. You need to know. 3 hours later. I love it. So any last questions or anything? Or Jay, you want to say anything to wrap up?
No, I mean, I'm available. If anyone has any follow-up questions, you can ping me on Twitter, _J Phelps, _JAYPHELPS. You can DM me or talk in public is probably the more ideal, just because other people might want to join in on the conversation. But yeah, if anyone's interested, if you're trying to get into WebAssembly, if you're using Rust, Rust is first-class support for it, so I would definitely recommend it. Assembly script is probably the second thing I would recommend, and then C and C++ has pretty good support with Mscripten, but it's kind of intimidating if you've never written C++ before. But if you're more interested actually in the lower level stuff and you're wanting to get involved in like learning more about the spec and these sorts of things, the community group, the people who do the specifications, it's totally open. You do have to sign up and sign a waiver and all that jazz, but you're welcome to join and just be a fly on the wall on the Zoom meetings and listen in or if you want, you can even give your input. It's very much welcomed by everyone.
Yeah, I love community groups. Cool. All right. Well, definitely follow Jay on Twitter _Jay Phelps. Check out Outsmartly as well. Really, really cool technology that Jay is working on and fun stuff too. That's using Wasm,
Yeah,
which is why I know you love it so much.
absolutely.
All right. And thank you everyone for joining us for this JavaScript Marathon.
Yeah. Thank you everyone for having me.